Hello everyone, this is Miss Detterman, and this video is part of a series I'm making on how to ultimately come up with a mathematical model for an equation for a graph, which just means how to find the equation for the graph using y equals mx plus b, especially if our graph makes a straight line like this one does, because y equals mx plus b only works for straight lines. So we'll look, and on this page, we already have slope calculated. We've already have y-intercept figured out. So slope's 14.55. The y-intercept is 0. Now, oftentimes students in physics aren't really picking up on how y and x need to become two new letters. They're practiced and they're used to in math class where they replace it, where they write y equals, and they'll put in their slope 14.55. Multiply that by x, and then add their y-intercept. They're used to ending here. Where physics gets weird is that we take it one step further, and this x and this y need to become a new letter. And the reason why they need to become a new letter is because in math class, when you're looking at these graphs, they just have it as y and x. They don't really have anything written on the y or x axis. In science class, we take these y and x and we give them some names. We label them, we give them a title, we explain what the heck was measured here and put it there on the y and x axis. So that means in this model, this y equals mx plus b, we're not just going to replace m and b, we also need to replace x and y based on what we have from the graph. It needs to be as specific as possible to this actual graph. So now y is no longer actually y. Y is actually what is written there on the y-axis. Y is technically extension. So y kind of sucks as a letter for extension. You would look at that and be like, no way, that's not true. Y can't stand for extension. So when we think about extension, let's look at that first letter, E. We're going to use that first letter E instead of Y now. So Y is now going to be E. We need to now do the same thing to X. Get rid of X, and now needs to be something new based off of what is there. And we have the word mass. That first letter of mass is M. So we're going to put X equals M. We now are going to replace X and Y with new letters based off of what is actually specific to our graph. So, with that being said, a good rule of thumb is to use the first letter from the word on the axis when you're replacing X and Y. But we do have a few weird ones. We're going to address these in class later, but for example, what I mean by a weird one is that there is this word called displacement. And in the world of physics, d equals distance. Distance got lucky. It got to keep d as its letter. It was there first. It picked it. It got it. But displacement is like distance, but different. It can't use D because D was already taken. It's already being used. So instead of D, they decided X would be great for displacement. Hint, hint, wink, wink. This is why we need to replace X now. Because every time you write these graphs and write these equations for these graphs and you don't replace X, a physicist is going to look at that and think you're talking about displacement. So when we are rewriting y equals mx plus b, let me erase all the things I wrote over top of it. We are now going to take into account all of the information we have that is specific to our graph. We know y actually is e. So when I replace this, I'm going to put e equals instead of y equals. Then I'm going to take m, which was actually slope, and replace that. So I'm going to put 14.55. Then x is going to also be replaced with its letter from the x-axis. So we're going to multiply by m. And lastly, add my y-intercept, so plus 0. Let's go ahead and simplify. E equals 14.55 m.